All right, Algebra 2, I want to maybe take a minute or two and think about what we looked at in the Desmos activity today and see if we can kind of make some sense out of this idea of an axis of symmetry and a vertex. So the other day when we were taking notes, we built a table of values in order to be able to graph the quadratic equation, quadratic function, x squared plus 2x minus 3. Right? And using the Desmos graphing calculator, this is how that would end up looking, right? So let's think back to the table that we built. We did a little bit of work, and what we decided was that the axis of symmetry happened at x equals -1. How did we get that? Well, we took a look up here. We saw that the b value was 2. So we know we have an equation x equals opposite of b over 2a that gives us our axis of symmetry. Okay. Well, if our b value is 2, the opposite of 2 is -2. The a value is the multiplier on x squared, which in this case, it's understood to be 1 because there's no number there. Okay. So we have -2 over 2 times 1, -2 over 2 is -1. So that tells us that the middle number of our 3 is going to be -1. Oops, that's not what I wanted. So in our table, where our x values were -3, -2, -1, 0, and 1. So we set this up on purpose because we know that the graph of a quadratic is symmetric, okay? This parabola is a symmetric object. It has one line of symmetry that goes right down the middle vertically. And when we say the middle, well, we found the equation of the axis of symmetry is -1. So we took -1, we substituted it into the function, and we found out that the coordinates of the vertex are going to be -1, -4. Okay? And so you can see that point there on the curve. And I'm going to go ahead and actually graph that axis of symmetry. This black dashed line represents our axis of symmetry. So we knew because of symmetry, we didn't need to substitute in all 4 of these other values for x. Okay? Because of symmetry, we knew that whatever the y value that went with 0 was, the same y value happened with -2. So when I substitute 0 in, that's going to give me my y-intercept because 0 squared is 0, 2 times 0 is 0, so y equals -3. So I plot that point on the curve. And then when we substituted in 1, we found out that when x was 1, y was 0. So I've got these 3 points. And so now I also know that when I substitute in -2, I'm going to get -3 as my value. If you look carefully on the curve, let me zoom in a little bit. So if I go 1 unit from the axis of symmetry to the right, axis of symmetry is -1, I go 1 unit to the right, I'm at x equals 0, and there's a point there. If I go 1 unit left of the axis of symmetry, there's also a point there at that exact same location in terms of y. Okay? It's almost as if I could take this curve and fold it, that these 2 points would match up on each other. If this dotted line was where I folded it, this point would land on top of this point. We also found out that when I substituted -3 for 0, that my -3 for x, that my y was 0. And again, I have this symmetric point, 2 units to the right of the axis of symmetry, 2 units to the left of the axis of symmetry. I'm going to find a point there as well. So this idea of the axis of symmetry, we know that in any parabola, there's going to be one vertical line that goes exactly down the middle of the curve, right? If I could imagine picking the thing up and folding it on that dotted line, then the points would match up exactly. So here my axis of symmetry, the equation is x equals -1. I found that by using -b over 2a. When I built this table, I used that fact to help me be able to graph by setting up my axis of symmetry as the middle point out of my 5. And then I used the concept of symmetry to be able to fill in my table. I didn't have to plug in all 5 of these values. I was able to actually, in this case, to only plug in 2 because I knew when x was 0 that y was -3, my axis, my y-intercept. So I'm hopeful that this visual helps us to make a little bit more sense out of the concept of the axis of symmetry. And then we also talked today in that Desmos activity about a vertex, right? That point where the graph turns around. Vertex always lives on the axis of symmetry, and it's always going to be the highest or lowest point on the curve, and it's the greatest or least value of y that's possible for the function.